Hello, everyone. Good morning. This is Suniti Mishra. I welcome all of my dear friends, colleagues, seniors, and esteemed committee members to my talk. I hope this is just worth your time. So I'll just start with a brief introduction. Recently, there was a publication in Nature Geoscience which was based on some very unique results which we had observed in Delhi. This was published in 2023, but this work basically started from 2017. So what happened was, we all are it's not a new information that how polluted Delhi is. We all talk about, like, there is so much pollution, there is so much concentration is so high, very bad for our health, etc. But like we tried to look into the reason and possible solutions which we can offer. So I have done this work under the supervision of under the guidance of my professor, Dr. Sajidanand Tripathi. And we also were lucky to have some good collaborations which were very supportive throughout the measurements and also through the analysis. So, okay, this is not moving. Yeah. So basically, what we started was, the data that we are presenting in this paper is basically of just 2 months. But what we did was, we measured from 2017 to January 2020. So we had 3 years of consecutive winters data. And apart from that, we also had in 2019, we measured almost all of the seasons, just to make sure that what we are observing is just not a night's event or a day's event or maybe a month. It has to be something which is happening there for like a lot of time, and it's very frequent. So the IIT Delhi site, so basically we had 3 sites. So if you see, the first one was IITM, which is a new Rajendra Nagar, and the super site was IIT Delhi. And a downwind site we also had, which was MRIU, basically in Faridabad. Now, these 3 sites were characteristically very different because IITM was mostly on the urban background side because it was on the edge of the Pusa forest, and it also had dense residential clusters at this site. Now, IIT Delhi is a very classical representation of urban polluted or mostly urban road side because there was around 200 meters from our side, there was a arterial road going on. So, and the downwind site was in Faridabad. As you can see, this is the Badapur industrial area. So a lot of industrial emissions were coming from there. Although this area is kind of scarcely vegetated, so like that. So basically, we wanted to see that whatever is coming here and here and here, is it regional in nature or is it just locally dominated? So yeah, we discussed the upwind side, the main side, and the downwind side. Now, let's begin the results. First of all, what we observed was, if you can focus on this plot, when we talk about NPF, when we talk about growth, it's a very critical process which starts from the basic cluster of gases. Now, when those gases have potential to grow further, then it comes to stable cluster formation. Now, when that stable cluster formation has the potential to grow, where organics and amines come into picture, then it grows to substantial sizes which are climate relevant and which can be detected. So basically, our measurements was starting from 20 nanometer and up to we had PM1. So this is a classical representation of what we actually observed. During the day, there was no growth as such observed. Like for the data that has been presented here is of around 33 days. And you would notice a very stark high frequency because around 80% of the days experienced high nighttime growth events. Now, by high nighttime growth events, I mean that generally we observe growth rates of 1, 2, 3, 5, 10 nanometers. Now here, if you take average growth rate from maybe 5 p.m. to around, I say, apart 6 a.m., the average will be quite normalized. So, but if you see closely, you see that the early, I think around 100 nanometer particles grow very rapidly, around 30 nanometer and 31.6 nanometer and 29.3. This is an average day what we observed. And once it passes 100 nanometer, the growth kind of slows and it's on average 10 to 15 nanometer. So this part is interesting because this part is the one which has very high growth rates, suggesting that something very dominating and very persistent is pushing the particles to grow, and they basically jump from 20 nanometer to 70 nanometer in approx 1.5 hours. That is quite high. And this is not just like one-day event or two-day event, as I told previously. This is what is happening regularly. This is just like 33 days of data. This we are seeing for like every winter. And in fact, in summer when the temperature is conducive, and the environment is conducive, we also see this. So this is a regular phenomena. Like we talk, like right now in Professor Maya talk, which was very interesting, there was a question that we have a lot of high pollution in the night. So basically, this is what it is actually making the high pollution in night and stabilizing it. Now, when we talk about growth rate, we are like, okay, it's high, it's low. Now, what does it mean? Now, if a growth rate is high, it means the higher the growth rate, the higher the probability of that particles to be stable at higher diameters. That means when it is stable at those higher diameters, it has the potential to alter the climate. It has the potential to substantially deviate the natural reflectance that we observe. So because of which, as you can see, this red thing is basically the high growth rate particles, which is up to 10 to the power 5. Now, as you can see, up to 400 nanometers, and if you see in this graph, the green one is still 10 to the power 4. It's around 500, 600 nanometers. So that means they are stabilizing the particles for a very long time at that diameters. And since in winters, we do not have much wind. We do not have, the particles basically just float in the air, and not float, I would say that they just stay there, so that it helps in the growth further, and they are not like dispersed quickly. Moving on to the next one. This is basically the difference between, if you see, this is the days when we did not observe any growth rates during the night. And this was the time when we actually observed some growth, not some, like huge, during the night. So if you see this column, it is about clean, if I have to like classify them properly. This is the cleaner days, and this is the basically polluted days. So let's begin from the first one. So if you see here, the particle concentration is very low. The particle mass average was around 72 microgram per meter cube in this time. And in this time, it was close to 300 or even more. Okay. And then if you see the organics, basically in the night, the organics increase. Now, if you switch to the PMF, which we actually performed on the organics data, which actually gave us 5 factors, which I'll come to in next slide. So if we put that into perspective with the growth, we see that on the clean days, the oxygenated aerosols dominate. The light gray, light brown, and dark brown are basically, this is HOA, and these two are BBOA factors. So you see that mostly it is dominated by the oxygenated mass, and we see no growth. But when you see in the night, the growth actually sharpens around 9. This is 9 p.m., this peak. And you see that the biomass burning factors increase very rapidly. They increase from like 10% to mostly 70% during the night. This is the average of all the growth events that we have observed. Now, there is also debate about chloride participation in the growth. When we talk about chloride participation, we also know, when we plotted the ammonium chloride and all the inorganics, we see that the chloride was actually increasing slightly with respect to our growth timings. But we also see that there is high water content. But so basically, chloride also looks like, here it looks like chloride plays a role. We'll look forward into that. And obviously the black carbon in the night, because of traffic, we have high, I think the average was around 44 microgram per meter cube for the growth days. And visibility and wind velocity is anyway very low, and visibility is obstructed because of that. In this plot, I showed that why this is interesting, because we are having a high growth rate in this regard. Now, in this plot, you can see that the particles basically from 25 to 40 nanometers and 40 to 60 nanometers show the highest growth rates. These are the ones that jump first, and they provide the base for the future particles to grow on that. So this is very crucial. Now, the other particles from 60 to 100 nanometer and greater than 100, it is still high, but kind of low than this. Now, to put into perspective, I actually plotted this with the other cities around this. This is around a combination of 50 papers, or maybe 60, from across the world. So if you see, the dark yellow is the urban polluted, and the light one is the urban, then the light, this is rural, and this is remote. So you see that these are actually very high. Now, if you compare the growth rates and the condensation sink with the other, like the detailed data that has been used for this plot, you also see that the red ones are actually pretty high. The condensation sink lies in the urban polluted range, and also the growth rate comes in the upper bracket. Now, I was talking about the chloride participation in the growth. Now, for that, we actually actually had site-resolved data about the chemical species, which helped us to look into what particles are actually having a major role in the ultrafine range and what have a major role in the bigger range, like greater than 100, accumulation mode range. So as you can see, this is like a typical graph for the growth rates that we had observed. As you see, this is basically 3:30 in the evening. And this is ammonium nitrate dominated in terms of inorganic chemistry. So you see that the organic peak is almost quite low. And as this is the basic start of event, we had an average start of the event between 4:30 and 5:30. Okay, so you see that the organics grow at a very rapid rate, especially between these two hours, and it continues to grow throughout the night. Chloride, whereas, they start to participate in very late in the night. So basically what happens is that when the particles are supported and they are brought up to a certain level, chloride rushes into, and it helps the particle to grow into unprecedented levels. Now, this is also a very important plot, because when we used this to see the sub-nanometer particle participation of organics or inorganics, we see that clearly we had seen no inorganics in the 60 to 80 nanometer in this we do not see any inorganics, and as we start increasing the diameter, we see slight participation. So this kind of proves that the organics are the main drivers of it. So it didn't correlate much with the AMS, and we had to move forward with the other analysis. So regarding the AMS data, we see that we had 5 factors, and in that 5 factors, we see that the BBOA kind of correlates the best with the growth. So, and the BBO that correlates much more with the growth in the chemical aerosol phase, which was also supported by the gas phase data in the biomass burning nighttime factor. And this factor was basically pushing out the gas particles into the aerosol phase particles, so which was actually leading to very higher growth rates. I think I have very less time, so that'll be all. Thank you. If you have any other questions, I can take it personally on my mail or as well as here. Thank you so much.
Okay, thank you. Thank you, Suniti. So, congratulations once again for the nice talk as well as for the wonderful paper.
Thank you so much, sir.
We can have 1 or 2 quick questions. In parallel, means stage setting can be done. Yeah.
So, your slide number 3, I was looking at some interesting phenomenon where, from 6 a.m. to 12 noon, you're showing a sudden, also burst of particle sizes, which is reasonably steep.
Yeah.
But of course, it's going from maybe 80 upwards.
Yeah.
So is that a different phenomenon than what you see with the really small nuclei forming at night, or how are they related?
Yes, ma'am, they are different phenomena, because what we do is we actually also use the air data, and also we see the wind data. So basically the wind was moving in the morning, and in the morning we also have some input from as the sunlight pitches in, so we have some dispersion. So that is not actually related to the biomass burning related growth, because the vapors were not showing that peak. So that is independent of it. That's why I did not highlighted that in this.
Okay. Hello. Actually, I just wanted a small clarification. When we talk of growth rate, what do you mean by that? Is it increase in concentration or increase in size of the particle you are talking about?
Okay, we talk about increase in the size of the particle. Now, I think your question was how to measure it. We actually plot the mode diameter of that range. For example, if we have from 10 nanometer to 1,000 nanometers, we actually plot the mode. Mode is the highest concentration at particular diameter. So basically, you plot the mode diameter, and you see if that mode diameter increases for at least 5 to 6 hours, you can say that that is a potential NPF for growth events. And obviously, for NPF, you have to look into the less than 5 nanometer data as well. But yes, for growth identification, you need a continuous increase in the mode diameter for at least 5 to 6 hours, as reported by many papers, and I also believe so.
Okay, so maybe there may be some artifact related to new particles.
More discussion can be done later. Huh?
Thank you, thank you.
Any last question?
Yes, sir, please. I would love to.
Congratulations for taking the bull by the horn. But then I think the question was similar one for me. If you go back to that slide, it gives the impression, maybe now you explained it as a model characteristic. Yeah, this one. it gives the first one, for example, gives the impression you are following a single particle dynamics. Perhaps you are actually following the series of photographs, running a movie out of it, but you are watching only the mode.
Yeah.
So you need to prove why mode is equivalent to the diameter. So
Okay.
why not the mean? Why not another moment or some such thing? But
Acha, about that
yes,
question. Okay, okay.
I am
get
sure
it.
there is.
Okay. Yeah, thank you.
Hello. As you said that in nucleation mode, the growth is quite rapid, you know. So can you say that we can conclude that the coagulation loss is dominant rather than condensation sink?
Sorry, your voice is not clear.
Okay. As you mentioned that in nucleation mode, the growth is quite rapid, say in less than 50 nanometer or so. So can we conclude that a coagulation loss is dominant rather than condensation sink?
Okay, this is a good question. Thank you for putting it like that. Now, coagulation losses, when we talk about an open environment, we cannot say, okay, this is happening, this is not, because simultaneously a lot of phenomena are happening. The question that we are dealing with is which is dominant, right? So obviously the coagulation losses are there. Nobody can deny that. Now, if we didn't have the vapor data, we could have settled for that. That was a good question. But since we had the vapor data, we could look into that the coagulation, apart from the losses and the origin of other vapors, we see that these are the vapors which are actually dominating the coagulation losses, and they're pushing the particles further to grow because actually they are a lot and in abundance in the environment. And when the temperature dips from 25 degrees Celsius to 5 degrees Celsius, and we have the RH steeping from, I think, 60 to 100, 95, it kind of helps it. So it just helps it, like, for example, there's a very strong vapors in this room, and you dip the temperature, they all start to condense on whatever surface they have. Just like that.
Okay, thank you.
Thank you.
Okay, so let us thank the speaker once again. Thank you, Suniti. So now I hand it over to Pallavi.
Yeah, I have a small announcement to make. For poster participants, we will have you all after lunch contact the organizing team, and you must remove your posters after your session is over, because we are having a parallel session, so it will be difficult for us to manage. And also for today's dinner, please bring your dinner coupons. That is compulsory for that. And we will be opening registration for during the tea break. We'll have a small tea break, maybe of 5 minutes. Please reassemble back. Thank you. Excuse me.
So everyone, we are back to the session. I hope you have had your tea break, and we now move on to the panel discussion session. And I would like to request, hello, please, can we quieten down? So we are beginning with the panel discussion session, and I would like to invite the panelists with me here, Dr. S.N. Tripathi, IIT Kanpur, Dr. Y.S. Maya from IIT B, and Dr. Gufran Beg. We all know him as the initiator of the Safar Network program. We had two more panelists, but unfortunately they are not able to join with us today. So we will not keep you away from your lunch for long. It will be just a brief discussion, since in the morning we were talking about air quality and reduction of air quality through smog towers. And since air quality has been in the news for quite some time, so the organizers thought that one session on air quality and various issues related with it, maybe that would be the, the required need of the hour. So we will begin this session, and since Iasta has taken up this conference after almost 4 years, and air quality was the prime focus of this conference, so I'll just request Dr. S.N. Tripathi to quickly brief us what issues are really existing, and how Iasta is trying to deal with these, and what can be done by such an organization like Iasta.
Good morning, everyone, and thank you, Dr. Sapra, for having us here on this panel. As you know, enough has been said about Iasta and its activities, but one critical challenge what we are seeing, basically when we face with this, what some people call wicked problem of air pollution, which is not only in India, it's across the globe. It's in fact one of the most challenging global environmental threat, is how do we develop capacity in the country. And when I say capacity, that is in terms of the human resources, and also basically putting up infrastructure which can help to have air quality management, robust air quality management systems at all levels. That is right from let's say at the national level, where the central government, takes actions, and it's a custodian, its regulator, Central Pollution Control Board, is responsible for keeping our environment clean, and in this case, air quality, to state level, and finally at the city level, which these days we call them as the urban local body. So we had one kind of estimate which was done for World Bank, which projects the total need of the human resource dealing with a very broad spectrum of air quality issues. That is not only, let's say, understanding the aerosols or some other kind of pollutants, but trying to bring out mitigation solutions or control equipments in industry, to all the way to the research and academia. This number would come to somewhere close to 1 million. So this country needs 1 million trained people who in some way will provide, expertise, technical inputs, or say technological solutions to solve this problem. So that is one thing where Iasta can play a major role, because we all know that aerosols are very central to the problem of air quality and air quality management, right? So since we already have a very good network of budding scientists, and then of course all the way as senior as like Dr. Maya is here, or Professor Beg, we can easily hook up to the problems and start providing solutions at all levels, wherever we are. In fact, in that direction, we also try to create a network. Some of you, I think, are part of that network, and some of you may like to join that, which is called as National Knowledge Network for Clean Air Program. It is a network of all IITs, NITs, and central and other national laboratories, where we have tried to create an MOU, because government always loves MOU, as you know, right? An MOU which exists at every urban local body where one of these institutions and their faculty members or scientists are active in the area of air quality or aerosols or environmental engineering, such that they can coordinate with the urban local body government and the state regulators to provide solutions in that direction. That's the one thing. Now, briefly, let's also touch upon the infrastructure need. Now, see, the infrastructure, when you try to have a robust air quality management system across the country, it starts with some basic infrastructure for monitoring. And as you know that, as of now, the footprint of monitoring is very sparse in this country. We have only 350 continuous monitoring stations across the country, which is just too little. So many of the cities, towns, emerging towns just don't have any monitoring going on. And there also, I think there is a need where Iasta, being a society of aerosol scientists, technologists, engineers, can come out with the solutions where we can add to monitoring, not to say that there are many other critical needs where also we can provide a lot of help and support. Thank you.
Yeah, so thank you, Dr. Tripathi. I think he has opened up the topic in a very nice way, touching upon several aspects, right, from monitoring and how the networks are going to help and so on. So Dr. Maiya was mentioning in his lecture in the morning that he was on this committee where several proposals came for cleaning up the air in Delhi. Now, which are the methods which work and which will not for open air? If we are trying to look at improvement in the air quality, what, according to him, what he visualized as he sat in their committee and the proposals that came, would be the best ways to tackle these kind of issues? Maybe you can take that.
Thank you. So, yeah, just one point maybe with Tripathi, what you introduced. Just I was discussing with Professor Srinidhi just now. So, something Iasta probably could do, considering the importance of this air pollution issue, which is connected to human health, is a certificate program on particles, PMs, behavior, very short. The reason I'm saying is, for some reason, because of too much of workload or too many things to learn, most people, including regulators as well as workers in the field, are not familiar with the simple things of particulate matter. You often ask people what does 2.5 stand for in PM 2.5. Very few will know the precise answer. There is no problem because today many disciplines have come to this field. Homogenization of knowledge is important. Iasta can start a certification program along with the lines of MP, Medical Physics Association or something. Universities can slowly depute. You can have your course in your class, but this is a specific certificate program, which is nice for you to have. You can always claim that I am Iasta certified, I know about PM. So this is one suggestion I thought I will introduce. Second thing I want to say is, again, is an old question since Bark days, indigenization of our instruments. We have to have, because now pollution is going to be our problem essentially. India and developing countries' problem. Maybe in the US when there's a forest fire, but otherwise not much. But so we need affordable instrumentation. Low-cost sensors are good, very nice. Also reference grade instruments. Maybe we should catalyze. This is, of course, I also talked about it when I was in Iasta. So, but then I passed that responsibility on to Dr. Sapra and the younger people, how to catalyze indigenization of instruments. Coming back to the principles which work, as I mentioned, many principles very nicely work in controlled environments. Electrostatic precipitation is a wonderful principle, and it was used 100 years before filters came. Cortels work, as I mentioned, and people knew charged particles can be collected. So, and it's used. However, there are problems with the high tension kind of a voltage system on a large scale with an unknown composition aerosols like in the atmosphere. So, but then maybe it can be used in some way, One concept we want to introduce is the hybrid concept. Today is a time when fusion goes. Everyone likes fusion music. So science also probably loves fusion and hybridization of ideas for cost optimization, electrostatic partly, pre-filters partly, ionizations partly. These are the three principles which work. As far as I know, there are only 4 principles which work: electrostatic principle, filtration principle, spray principle, more or less. And there were exotic principles like acoustic. People tried in the 70s, especially in the airports, to get rid of fog for land takeoff. Very high intensity sound, but not troubling people, not audible sound at that higher frequency, hoping that some coagulation-driven collapse will take place, but it didn't work. That principle is not really currently used. Maybe in some confidential military applications they might use, but it is not in the public domain much. So I'm not really aware of any other principle. Maybe if I'm missing, somebody can add. But then filtration is robust. So we used filtration because we didn't have chance to explore. It had to be done with known principles. So I feel on the scale, core will remain filtration. It is the bedrock. You can have add-ons to improve the quality of filters, and again indigenization. Is that, I mean, whether it is outdoor or indoor, filtration indigenization is going to stay. I mean, the requirement is going to stay. And I feel that the more we develop experimental technologies, more, the fact that so many public entrepreneurs came for outdoor air cleaning itself was a heartening thing for me. To see so many people showing the filtration curves, showing various ways of making sprays, very fine droplet sprays. There is so much of entrepreneurship in people. So I suggest that could be exploited to actually develop a feasible technology. And Iasta, being of course the collocation of all pollution scientists, can have a role. Another role for Iasta, I would say, is of course the COVID kind of a bioaerosol research is very important. We are going to have these kind of things in the future. So Iasta definitely, I was really waiting during the COVID period whether any of us can have one write-up in the public domain, because I don't think anyone in principal scientific advisor or anyone knew there is a discipline called aerosols which have to be spoken in this occasion. I did not say anyone. Myself and Anand, we were thinking we'll make a write-up along the lines of the European aerosol. They had come out with a pamphlet, what to do, what are aerosols, whether ventilation will work or not, what we should do in this time, all this. So again, it's a natural. We have so many problems, so that's one direction where Iasta can popularize. So I think this is briefly what I want to say.
Yeah, so I think as Sir said, that filtration is something that we have a lot of experience and expertise, and now we do get indigenization of HEPA filters specifically in India is possible. We have several companies who are doing this now. The one thing I always feel that the people who are in this aerosol field, they have an edge above all other, however big scientists or engineers they may be, and that is understanding the efficiency of filtration. When we say that 0.3, Sir also pointed out, that very rarely you will find that people from other disciplines would understand that when you say 0.3, that is the the size at which you will have the minimum efficiency, and above all these sizes, the efficiency is going to be close to 100%. It sometimes is very difficult to make people understand why this happens and how this happens. So I think that's where we all have an edge. And coming to, rightly as Sir said, that regarding the role of Iasta, I think we are all experts in the field, and coming together on such topics is always helpful. With respect to COVID, many of us did have publications coming out, because COVID, after all, was in the aerosol form. So all our learnings about aerosols apply to this. But yes, specifically, a small note for the Indian government, for the policymakers, for the community, probably that was lacking. Although a good number of scientific publications did come out from our group. We had 2 or 3. Dr. Maya with Anand, they had some theoretical calculations. I'm sure many other groups also would have published. But yes, maybe Iasta can take up this kind of.
Mask testing, yeah.
Yes, we did a lot of mask testing. A lot of indigenous N95 masks were being developed in the country, which came to us for testing before it could be given to a certified agency to do the tests. And that's how we really helped the Indian community and the vendors to develop good quality masks. But yes, if an organization like Iasta comes out with a note which is useful for the people of India to somewhere say that yes, this community is available in India and we are aware and these are the things that are being done in this field, at least by the Indian community, that probably helps, because not many would be reading these publications which come out in very niche areas or niche groups. So we also have with us Dr. Gufran Beg, and he was, I would say, one of the first initiators of a networking kind of a program like Safar. So Dr. Beg, can you please tell us that when you conceptualized this project, what were the hindrances, or was it so easy for the government to understand and provide funding for this kind of a large-scale project? Because it does require a lot of money to set up these networks in various cities when you're going. So what kind of a reaction did you get from the policy makers when you started with this?
Okay, thank you, madam. In fact, giving the answer to this your question is, that time there was not much of a problem, but there are problems now for last 2 years. So anyway, I will come to that particular thing. Now I think both the speakers have already talked about Iasta's role as well as the what control measures and what can be done. What I will be talking mainly about what is really a problem of Mumbai. As far as air quality is concerned, what is the problem of Mumbai, so that we all are talking about. Delhi is fine, Calcutta is fine, or other cities, but what is really a problem? Now, most of the Mumbaikars, God is very kind to all of you, were very kind out of you 2 years back. Because this is one of those cities which is surrounded almost 3 sides by the ocean, and by the virtue of that particular meteorological phenomena, you can't have a calm wind conditions here because of this, as well as there was a wind reversals. So natural protection is very well covered as far as Mumbai is concerned. Just those people from Delhi or surrounding region, they are cursed by the nature as far as the air pollution is concerned, because it's just opposite of that. It is a landlocked city. Now the question is, why we are talking about air quality in Mumbai now? There is a problem that air quality, in spite of having such a natural protection by the nature, we are facing a problem of air quality. We see the skies are becoming brown and black, and there are consistently problems. There are medical data which are all there. So let us talk about that particular thing. In 2022 winter, compared to past 10 years of average you take, air quality has deteriorated by 30 to 40%. Now this has happened. You can't increase the emissions by 40% in 1 year. So that is a ruled out thing. The only thing what is happening is there are redevelopment activities are taking place. There are, coastal corridor are there. There is a dust and all those kind of things are there. So those things are anyway adding to that. But then where is the problem? Now came 2023 October, November. We are again seen the similar problems in October, but fortunately not seen in November, that particular thing. So where the problem lies? The problem is very clear that nature, which was in your favor, are playing with you now. They are trying to tell that, yes, I have a capacity to a level, beyond that I am not with you. And that is what exactly it has happened in 2022. There was an unprecedented, unusual phenomena which has happened in Mumbai, that winds all through October, November, December was much calm as compared to whatever you see for last 10 years. Now why it has happened? Why natural advantage is going away? So there is a phenomena which we call is a ENSO or La Nina. Well, you must have heard that phenomena only in terms of a monsoon when you talk about, but now the point is that phenomena is related with the climate change, and we are working now on COP28, and I will be anyway talking about in this era whether those climate activists who would like to distance themselves from air pollution problems, whether we can come to the same stage. And that is where the time has come. So to summarize just, and coming back to finally for 30 seconds for madam's another answer is that basically climate change is meddling with a lot of things. That kind of an unprecedented calm wind condition never seen in last 1 decade has happened in October, November, December in 2022, which is understood to be because of the large scale circulation, La Nina, which has forced this to happen, which was again first La Nina of 3 years extending, first time in the century. That has happened. But anyway, 2022, something is there. Now coming to that particular thing that in 2015, this has been, established, the SAFAR system which I was talking about. It was a lot of difficulties, lot of all those, but then that time the secretary, Professor Nayak, who was really a visionary man, and he has seen that this problem down the line in 5 to 10 years are going to be a big problem. At that time, if we are not prepared with something, then we'll be left behind. So let us have a frontier this thing. So we started, in fact, in 2010 Commonwealth Game in Delhi, we started. That time there was a problem. There was a huge amount of correspondence which was going on that if you show the air quality in a red or maroon or something of that kind, then there might be a backlash. That will be a political backlash in the sense that people from other country may go and all. So you have to be very careful. So looking at the long-term benefit, I kind of agree to that particular thing. So we'll play down when it happens something, we'll put our displays off or something like that, So all those things were there, the point. But then we are seeing a long-term battle now. Delhi, as far as concerned, everything is transparent. There was 5 years, 10 years back, there was a problem. No, this you don't show 300, don't show 350, don't show maroon and all. Similar kind of issue, trust deficit, we are facing in Mumbai now. So we have to come out. This scientific community has to come out. You can see from the naked sky there is a problem. You can see from the health people there. But there are somewhere there is a trust deficit where after 7 years you start questioning to the scientific, establishment of some agencies. You may not be correct, you may be right on all those. So anyway, we have to come above all those lines and that is how the thing says. So you have to have a courage. You need to start something. You should have to have a vision that what future would look like. I will be touching upon those future aspects for the benefit of youngsters that you should have to embark on that. So I think I will start.
Yeah. So I think we had the SAFAR program and now a lot of low-cost sensors networks are also on. Now, if as a member of, the common member of the public, if I have to ask that having spent so much time, effort, resources into this kind of networks, is our purpose only to show the common man what is the level of the NOxes or the SPMs or PMs? In what way is this monitoring or these display in the common domain really advantageous to the common man? What is being done to look at these values and try and see that what kind of regulations or policies need to be in place to bring this down? So was this network ever used by the various agencies to bring down the levels? How far this network has been used? Yes.
It's very, very good question, and that is where the concept of air quality index came in 2015 by the government of India, although we started in 2010. So the point is that awareness creation. When I traveled to rural areas, I had an opportunity to do to Punjab and Haryana, stubble burning, and many other areas. I find that our poor people, most of the citizens are hungry to listen to the knowledge that if air quality they hear, PM 2.5 also know. In whole of Delhi, Faridabad, UP, that area, people know what is PM 2.5, which is not good for us. And it gives dama. That much people know very well. But they don't know anything more than that. So if awareness creation is, I think it is one of the best thing, which is required at this stage of time. We feel that we as a scientist know a lot of things, we assume that other person will also be knowing it. But I think that awareness.
With that awareness creation, if he knows, okay, isse dama hota hai, I'll get asthma with this. But then when you tell him that chulha mat use karo or this, does that reach to that level where you are able to convince him that it is because of this source that you are getting this dama and you should stop using this and use this instead? Does it work?
That is exactly the very complicated problem that should have worked, but again the socio-economic conditions comes in picture. For example, a farmers, majority of them, they say that even if you give us something in 5,000 rupees to cut and dispose of this, they say one ek machis ki tili se kaam chalta hai, to what I should go for this? Why I should go to 5,000 rupees? Similarly, when you are there in a village, then the lady who is cooking 2 hours in the morning, 2 hours in the evening, with a 6 month or 3 months child on her lap, no ventilation in this, there is nothing, she has to do that wood. So, that is the reason that you will find that during the winter time, in fact, they suffer much more, but not in a summertime, because summertime they come out in the morning when there is something and they open it. So, those are the issues we need to deal with that. As far as you look from a purely a selfish air pollutants, environmentalist point of view, yes, it should be closed. But then there is another question is that all the transport should be stopped because they give 40% of the pollution. But we can't do that. So there is a socio-economic angle that also need to be very delicately tackled, and that is where a lot of people take advantage of getting into mitigation aspects. So.
Yeah. So, Dr. Tripathi, as I said, he has been working with low-cost sensors and good network has been established. So, Dr. Tripathi, can you tell us a little more about this low-cost sensors and what is finally going to be the end point of this? What are the issues that we are facing with these low-cost sensors? Because we do hear both sides, regarding the calibrations and the accuracy of the data being generated by these networks. So, what would be your comments on this?
So see, that the whole area, or let's say ecosystem around low-cost sensing, I think took off around 2014 or 15, right? Now, if you see where it has come, most of the monitoring-related protocol standard, Professor Beg would agree that we follow US EPA. Now, US EPA has started using low-cost sensor to, for example, monitor fire-related emissions and how it is impacting air quality. In fact, they had quite a few recent incidences of large-scale forest fires in Canada, in California, and the plume impacted right from the East Coast, New York, to all the way up to the West Coast in San Francisco, etc. And for that, they have actually created a network of no less than, I believe, 10,000 plus sensors, where they are basically issuing these real-time alerts, advisories to the citizens that to basically take informed decisions about their outdoor movements. This is just to give you one example. I'll give you one more example. Seoul, which is basically kind of our Delhi national capital region of South Korea, is not a city, it's a city conglomerate. And they had been facing a problem of air quality just like we are in Delhi just about 5 to 8 years back. And their main issue was that how to increase the regulatory compliances of different kind of, let's say, people who are operating point sources, let's say small industries to maybe even medium-sized industries, and many other such sources. They augmented their regulatory monitoring network with about 15,000 sensors or little more, so that they were able to place one sensor in every half a square kilometer grid in South Korea. And this is a full report, which is published on UNEP site, okay? Which shows that in 4 years, their regulatory compliance increased from 10% to 70%. This is just to give you one example that how the sensors are helping in a variety of ways. I can just list for the, in the interest of time, that first, that there is a global consensus that for PM 2.5 measurement, we have a reasonable accuracy. But then there is a trade-off. When you are buying a BAM or EBAM, what the government agencies are using cost you 20 to 25 lakhs compared to a simple sensor which costs you probably a few tens of thousands of rupees. And if you create a full unit which has everything for, let's say, from sensing to transmitting the data, data storage, and maybe you have your self-harvesting energy system, it costs you 50,000. So in lieu of one such BAM, you can actually place easily 45 to 50 sensors. That you can just imagine that how you can increase the overall footprint of monitoring wherever you are trying to monitor. The one immediate outcome of that is that you have a very clear idea that what you are being exposed to at a hyper level. Because our main concern today is that what people are breathing and how their health is impacted. That's one thing. Now, this is only giving you some kind of information. Now, I tell you another very practical example. Uttar Pradesh government, where we have a very large sensor network now emerging, and Bihar, we have put a very large network, is trying to create now a state capital region around the city of Lucknow or district of Lucknow by pulling in 5 adjacent districts. It's just like you have Delhi NCT, which is a conglomerate of about 25 so districts. If you add to make it NCR, this is about 50 plus districts. And they want us to create or give them an optimal solution for city planning where the polluting sources, the road, the road arteries and all those things are placed so that the habitats or residential areas are minimally impacted. You see, these kind of things where you have this hyper-local monitoring can help in a very, very precise way. The third thing they are now also trying to get into is what something is called, some of you know, is called air quality management at a airshed or a micro airshed, basis. And there also we can do. So not only that, you have better information for having, better awareness amongst the people, you have more accurate health assessment. And third, you can also help different level of governments from city to state to national to devise, design better air quality management. And finally, that if you have any interventions, which have been talked about since the morning, any outdoor intervention, its efficacy also requires to have these kind of measurement which can give you enough data so that you can see whether the intervention is working or you need course correction or you need to altogether shelve it. Yeah, thank you.
Yeah, I think that is what we were looking for. So you have partly answered what I was asking Dr. Beg, that having measured the levels, having a good network for it, but if the bodies who have to take action, if they remain closed about it, they remain ignorant about it or are unwilling to do, then this whole exercise has not much of a meaning. So just as we know that in Mumbai, a lot of construction activities are going on everywhere with the metro coming up at several places. And obviously this is contributing to the bad air quality that you see in Mumbai. The bodies like IITs, probably the government or the municipal corporations like to hear from them more than anyone else, and they rely on what they say. So does IIT Bombay also have any linkages with the municipal bodies here to advise them or recommend, on issues of how to improve the air quality and so on? That maybe Dr. Maya can answer that, or from IIT Bombay, I don't know, Chandra isn't here, maybe she would have been able to answer.
Yeah, Chandra and Manoranjan, I think, has some, maybe he gets some phone calls.
Okay.
From
this
thing, from BMC or something. Can I call?
Yeah, sure.
Yeah, so regarding Bombay air pollution, I was in the part of technical advisory committee meeting and I have attended a couple of meetings. So the discussion is happening, all kinds of things, but however, the action in the ground is needed. right? Whatever Professor Tripathi said, we can do the measurements. We can say these are the measurements. So what? A proper enforcement has to be done, and again, any intervention has to be measured. Then only we can say that something is working out. But however, I do not know whether IIT Bombay is, as far my knowledge is concerned so far, IIT Bombay is not intimately involved in the BMC and all kinds of activities. Because I was the person who was invited many times. I have gone twice. After that, I have decided not to go. There are several reasons.
Professor Sethi is involved with the CPCB.
I think Professor Sethi recently has been involved, and he went to a couple of meetings regarding this. But again, yeah, all the things are happening in the discussion stage. And as far as I understand, Professor Sethi has suggested many things also. Like a lot of technological interventions has been discussed in ongoing, right? In Mumbai, I see that in the newspaper, putting the filters on the bus, all kinds of things, putting the purifiers in the gardens, a lot of things going on. But without understanding the basics, whether even this works, whether fundamentally these are correct. This is what I attended the meeting. I questioned some of the technologies. Even people do not understand the basic principle how it works.
Yeah,
And
in
then
fact,
somewhere they are able to convince
we were hoping that the Municipal Commissioner of Mumbai will be here with us today. She had promised she would be here, but yesterday we got a message that she's unable to come because of some pressing reasons. So we thought that this would have been a good platform to put them across that there is a community, and please involve them when such decisions or activities need to be taken up. But unfortunately, she couldn't join us. Yes, Chandra, you were trying to say something.
Yeah, just to add to what Manoranjan said and to the discussion going on here, that indeed, as you pointed out, it is the measurement of the level is a first, evidence. However, this apportionment quantitatively of sources affecting air pollution in sort of a time frame, along with what Manoranjan mentioned, which is that what are the measures, and we need to have a quantifiable index that these measures are implemented in a long term. You see, we cannot have a conversation only in October and November, only in the Delhi NCR or North India and expect to solve the problem. The problem is solvable. And I think that among this group of aerosol scientists, both on the measurement side and on multiple methods for source apportionment, which of course many of us are familiar with, we know enough to act. Now it is a question of having the action quantified over a period of time and see whether, the action implementation of interventions over a period of time can be tracked. And then does that correlate with what our models, what our measurements, what our other methods of source apportionment tell us is the way that the sources are changing? If the person like, the regulatory group tells us, I have cut this source by this much in terms of emissions by doing this, this, and this, we can very easily say, that should be reducing your air pollution by this much. We're not seeing it on the sensors. Let's go back and get our implementation. So this kind of closed loop is what we need to set up.
Yes,
and
so I think
we are very much
Correct.
ready for it and
Right.
very much wanting to do it.
Right.
And I'm sure that we will find people on the regulatory side to support it. But the implementation, as Dr. Maya said, getting 2 smog towers set up is a huge implementation effort.
Right.
Getting sources closed down is going to be a huge implementation effort.
Yeah, so the implementation and the interventions is something that we really, I don't know what this community can do to, bring upon the regulators that this is needed, and then we are there to see whether the effect is there and the impact has been made. So I think, yes, we are opening to the floor maybe, and as the questions come, maybe the concerned panelists can answer. Yes, please.
Yes, I would have a comment. So I think these networks, I mean, to measure PM 2.5 or so, I mean, a lot of sites, I mean, has its value. But I think it's really important to really have, in my opinion, some super sites where you really can assess in detail actually the sources and actually, if possible, even track these sources in very fast. I mean, as the lady just before me said, I mean, one wants to prove that certain measures really had an effect. And if you measure only total PM 2.5, I think it's very hard. But if you have in very fast response, maybe, a day after or, really online, actually, you can see, I mean, how much is which source actually contributing to the PM. I think it would help a lot actually in figuring out actually which measures did what and what can one do in the future. So I think a combination of PM in many places, but then, for example, for Mumbai, one could think about just one or two super sites where one would have really, I mean, sophisticated instrumentation to run in real time and also do long-term analysis in depth. That I think would be a good combination and I mean, I think very valuable for evaluating further measures.
Yes, I think that's a good comment made. Yes, Professor Prastonis is trying to say something.
If possible. Well, if I can offer my view here, because India is a fabulous country where democracy is also very ingrained into the system, and somehow I come also from Greece where democracy also. And I started my PhD studies motivated for fixing the air pollution problems in Athens. 40 years later, I can assure you that still the problem is there. And I have the feeling that this problem will be here for some time. For the same reason that in Los Angeles, I saw during my lifetime the conversion from the real heavy pollution to actually to be cleaned up. Why? Because in the United States, the rules are obeyed and people actually behave and respond. The same thing also we see in China. We see an improvement in China because of the government is actually very strong in certain areas to apply. But in Greece now we see improvement, but the improvement actually happens only when we in this room take action. My friends actually, they went to the elections, they became mayor of certain areas, and actually then they enforced themselves. So we have to do the job. So if you really want to make a change, as I say to my students, you have to be involved in the local level, go to the elections, become actually the bosses of the regulators, and then something may happen. Now, at least that's my narrow view of this.
Yes.
Of course, I don't know how this can happen.
Yeah.
Hello.
Yes.
I would just like to add one point, because when we consider the network of sensors, so one important requirement, what I feel is that geostatistical data fusion. So the suitable method we need to find out, because we have data in the point locations. So we can implement or combine that with the satellite data. Now we have geostationary satellites. So that will give like periodic information every 3-hourly basis. So if we have a proper calibration with the, comparison with the ground-based sensors, so, and the long-term data, that will be useful for predicting as well as interpolating the missing information where we don't have the sensors. So that we can look into that. That will be one important criteria.
So I think these kind of studies are already being done, right? Comparing the ground-based measurements with the satellite data.
What I'm saying, the data fusion and then interpolating between the missing locations, because point locations are in a distributed domains, but we don't have information from one point to another location. But how it varies from one location to another, exact information normally we don't have. So that information we can get from satellite, and then that fused information we can use for model predictions.
Yes, I think your point is well taken.
Yeah.
Yes, Shuklaji.
Can I have?
I think the discussion was very stimulating. When we have realized that cars cause pollution, so now Bharat 4 and Bharat 5 things are a part of the deal. You cannot sell cars without those standards. Suppose aerosol scientists could work and propose similar standards for road construction, that if a road is polluting, you can have air curtains, you can have water scrubbers, and these are the guidelines that have to be followed if the ministry has to give a contract to some person to build a road. The same holds for buildings. You see buildings, just a green cloth is there, just a sham to show that no dust is coming, but we all know it hardly covers any, whether it does. So if certain guidelines are made into activities which pollute, like construction, like building construction, road construction, and standards are set, and Ministry of Railway or Ministry of Road Construction and others, they are supposed to give tenders to compliant firms who comply with those standards, just as you cannot sell a car without a BS4 or a BS5. Similarly, those activities cannot be done. And if the regulatory authorities are given a protocol that these have to be followed and results are shown, that if a road is constructed without a water scrubber, this is the level of pollution, and if water scrubbers are used, this is the level of pollution. I think just as plastics have now come into our social consciousness and people refrain from using plastics, similarly, if that type of social consciousness has to be built and some regulatory mechanisms and protocols have to be advised. That is one thing. And just winding up what to Dr. Sapra said, see, this is a interdisciplinary area and people from many domains come here. So, I mean, I have a background in fluid mechanics and heat transfer, so I could understand the boundary layer and the thermal jet, but I may not understand the chemistry of many things. So, if we really want this science to develop and not be very speculative in nature, I think some short-term certification course, maybe on NPTEL, they can be made. And people from different domains can add up to the knowledge so that aerosols remains more of a science than maybe a fantasy. Thank you.
Yeah, thank you, Shuklaji. Yes.
Good morning to all of you.
I don't know if they call for an answer.
Ma'am, I have a question.
Yes, please.
First of all, thanks for organizing such a conference in city of Mumbai. This is a very, very specialized technical subject.
Can you introduce yourself? Where are you from?
My name is Prahlad Adhikari. I advise Uttarakhand Council for Science and Technology on development. I'm a resident of Mumbai, but I've been settling between Dehradun and Mumbai. So because the subject is air quality of Mumbai, so my first question was, because I'm taking the layman's stand, is this air quality problem is only of Mumbai or metro cities or mega cities, or is the situation is so bad that it has started affecting villages also? So that's the first question. And second question is, because there's a lot of research has happened, it must be happening, and air is very critical element of life. So where does it relate to the disaster in the overall thinking, and do we have any early warning systems or those kind of systems available so that a layman's life is saved and it doesn't become a disaster? Thank you.
May I, sir?
Tripathi can take that.
I'll just take the first one. See, this year when Delhi NCR had seen, I think, one of the worst pollution episodes since 2018 or something like that. I think they say in last 6 years. I think for a couple of weeks, or not, if not weeks, Bhopal, which we never thought would have such a extreme pollution, right? Because it's a little bit outside the Ganges Valley, right? Which we feel that had this perennial problem because of its geographical location and prevailing meteorological conditions during winter. Bhopal has been, topping the chart for 2 weeks, I think somewhere from 5th November to 20th November. So this just give you one example that this is no longer a Indo-Gangetic plain specific problem. And I think there are problem also sometimes is seen in Guwahati. Certainly there are small places in Rajasthan, you will be surprised to know. Just that time I was looking into these data very actively. And there is a place called Hanumangarh, which is just on the boundary of Delhi NCR, has consistently PM2.5 exceeding 400 microgram per meter cube from 1st November to, at least I followed it up until 13th, 14th November. We know that problem is there right up to Mumbai. I think the only reasons which probably remain untouched would be part of Kerala and maybe entire Kerala and a good part of maybe Andhra Pradesh and Telangana. Even you again will be will be surprised that Chennai, where we have a modest size sensor network, has been seeing this exceeding PM 2.5 compared to the national standard at several locations in winter. So now you see that Chennai actually has even stronger this cleaning out mechanisms than Mumbai, and that also is seen. So see, right from, I think, Punjab to Chennai, and then from Mumbai to Guwahati, we are facing this problem. So that is what is the scale. Around second question, I don't know what is it. And somebody
He was asking about alerts, whether some warning alerts, warning systems can be designed. Yeah.
See, giving a direct pointed answer to your both the questions are that the air quality problem is a national-wide problem. It's not only Mumbai problem. But the point is that majority of the places in the rural India, we don't have even measurement, we don't know what is the situation. I have a very strong feeling that ozone is going to be the dominant source there, whereas here particulate matter in the cities. Now, why only Mumbai is talk, why only Delhi is cut, and that is where exactly the question of professor who has asked about that political agenda comes. Maximum awareness where it is, where the maximum coverage is there, it is going to play. So we need to have a awareness creation and educated people outreach activity, which is maximum in Delhi, and that is what it was in the even assembly election political agenda also. And that is what the professor was talking about. So awareness creation was kind of a problem. Everybody need to know, then only it can come. Otherwise, it cannot come into that. As far as his thing is concerned, whatever you talked about these guidelines, they are existing for years. And in fact, in 2 months back, even Mumbai BMC has again issued the similar kind of a guideline. Problem is a implementation, sincerity in implementation. And that is where you need to focus about.
So I think Chandra was trying to make some
Can I
comment.
just
Yes.
add, if you don't mind, very quickly to the very important points that were made here. One is, from a variety of modeling methods, we are able to also say what is the air pollution all over India at reasonably high resolutions. And indeed, 70% of the what is called morbidity and mortality, the impacts, are lying in non-urban, in rural areas. So the air pollution impacts are preferentially being experienced by our fellow citizens who are not in urban areas. And that is one. And the other is, yes, in terms of alerts and other things, of course, we need to understand better the acute effects of exposure to air pollution. And already, I think alerts and warning systems are there. But again, as was pointed out, the emission control is really the only final lasting, solution to the problem, while we support it through all of these other ways.
Yes, yes. Yes, please. Yes, sir.
Yeah, I'm just adding to the points. When we talk of rural pollution in India, I think we are missing the indoor pollution. Largest population is exposed daily to biomass burning, and maybe because newspaper people are all in the cities, so this doesn't become public. But if you honestly see the totality of air pollution exposures, I think we should also include air. I myself and Chandra have spoken about it many times. And also, indoor pollution, I think 75% escapes outdoors. So if you calculate the deposition velocity and rates, it's about 25% only gets trapped inside. Where does the rest go? So huge population, large biomass burning. It's of course dangerous inside. Nobody has this, and also contributes to outdoor pollution. So this is just a point.
Yes. Yeah.
I think one thing which I just kind of has a pressing kind of, feeling to highlight it, that, what Professor Prasni said, that it's a large country. We know we have a very thriving, deep-rooted democracy. So therefore, I think the data is going to play a major role in, making critical decisions in every sector. I mean, all the points were touched here. And so this is where I think, as aerosol scientists, I just want to sensitize it, that just don't worry. I mean, that thing is over, that whether there's a 5 or 10% of error. Data itself can correct itself if you are working with the right kind of computer scientists. The overall evolution or the growth in machine learning, AI, and data science is so rapid that if you can hook up with right set of computer scientists, I think data can give us a lot of information, can enable us in decision making, and I think that is where probably the way ahead is.
I think we are overshooting. The organizers are continuously telling us to wind up the session because the next session has to start in time. So I think I will thank the panelists over here. And any questions that you still have, they are available. You can always have discussions outside the sessions during lunchtime or otherwise. So thank you once again, and thank you to the audience for having contributed very well to the panel discussion. Thank you so much. Give a small memento to our panelists here. We are having Dr. A.P. Dimri. He is the director of Indian Institute of Geomagnetism. And we are happy that he's here with us. So I will request him to hand over the mementos to our panelists. So Dr. Dimri himself is a atmospheric cloud expert. A lot of experience in atmospheric modeling and cloud-related studies behind him. Thank you. No, sir. To me also. Thank you very much, sir. I'm glad to see you here. So I think with that, we close this session. Yes, one photograph. Thank you. Thank you very much.
A very good afternoon to all. So we are moving to the next session, and we are going to have two very interesting talks in this session. So may I first invite Professor Gufran Beg, sir, from IIC Bangalore. He does not need any introduction. He is going to talk on transport modeling for aerosol forecasting. I think already he has been introduced. Without much delay, I would like to invite Professor Gufran Beg for his talk. Sir, please.
I think you heard enough my voice. So I don't want to, I will not speak much, only I will show the slides. So this is basically what I will be touching here is very simple. I think if you pay 50% of the attention also, you will be able to understand. Very simple talk. Well, this design itself shows that how complicated is the, we are going to go in the DNA of the air quality, where you have to understand. Modeling is such that in addition to simulating what observations does, it also tell you to why it is happening. So that's how it is important. So it is good for the interpretation point of view. So since it was a modeling related talk, I thought that for the benefit of all you people, I will start that modeling in the atmospheric sciences started when. So this was the first grand challenge, was numerical weather predictions. And these are the, I am not going to read much, but these are the people who are pioneer when the modeling word started in atmospheric sciences. And then that was the first. So in our country, air quality, climate and all, not even country, all over the world, the weather model concept in atmospheric sciences came from the weather. Then from weather modeling, there are in between, there are a lot of challenges, a lot of things, but then come to this where the modeling for the climate modeling started. And in this particular thing, you must have seen a couple of years back, Professor Manabe, who got the Nobel Prize. So he started some 50 years back, 40 years back, has been recognized in this time. That is the reason that for any subject, awareness creation and outreach is very important. So work was existing in 1982, 92. Then after that, of late, when these, out of these three, the last gentleman, who was a pure atmospheric chemist, he got a Nobel Prize in 1995. Importance of atmospheric chemistry has been realized. And that is the reason that in the all the models, atmospheric chemistry was included. But the moment atmospheric chemistry comes, then you are in business. You have a air quality problem and all. These are all the people who are all there. So the point was 1970 onwards, how the offline model, 1985, 92, 97, and the present era, where computational powers are increasing and everything is happening, all these processes, how it got evolved with science. And then you are in the present era where atmospheric chemistry, so when you put it atmospheric chemistry, 70% of the computer time it takes. So people, when you are not having a computational power, you are having all those kind of things. So, but then, well, we got saturated in the model, skill need to be developed and all, things were going on nicely, weather was getting predicted. We have a early warning system, one of the gentlemen has asked, it is there in Mumbai, Pune, Ahmedabad and Delhi for last 5 to 10 years. So you can see suffer dash ape, air, ape and many things. But then the problem is not prediction and all, that is all WRF came, several models are there which are freely available, you can do it. It is like, you know, garbage in, garbage out kind of a thing, or something very good thing you do. But the major problem in this society as today is concerned is that frequent extreme pollution event in an era of climate change, or what I call in an era of COP28 going on. So that is threatening health and food security. Then in Mumbai, sometime in the first week of October 18, this was one of the photographs which was taken 2 days before, and suddenly from the second week onwards, kind of thing, same place, same kind of a thing, just taken in all those. So the point here I am trying to draw here is COP28 is underway and global focus in climate change. Parties are silent on air pollution. I think I have been following it for 2 weeks. Maybe in one of the sessions, pollution was mentioned, but then immediately it was silent. Global change appears to be knocking the door of air pollution more frequently than ever, and that is what I will focus on. Humans keep on burning fossil fuel and biofuel, pollution will worsen, and so will the climate change. At the end of the day, clean air will lead to healthier pollutants. So should not we talk air pollution in COP28 or such kind of a meeting. And that is again the knowledge, outreach, pressure from all of us has to come into that. So the point was that one of the talks, when we are talking about the climate scientists, you wanted to convince them, we have shown these slides. If you improve the air quality, health will improve. So decrease the PM 2.5. Now decrease the black carbon, which is one of the greenhouse gases, which constitute one of the most dangerous health point of view part, which is much more higher in percentage in Mumbai as compared to Delhi or many other North Indian cities, which is more of a dust mineral related domination, whereas here black carbon and organic carbon related these things. So this kind of a strategy will win there. Well, then this is not to explain you, this is just to impress upon you that we in India are very advanced in doing this, and I think the time has come when the globally also people are doing. So this was one of those models which is suffer models which was developed in 2010, which has extended to number of cities, which has a weather component, which has a chemistry component, then city network, and then these all supercomputer facilities and all those things are there. But the point is that now even we are working those things with artificial intelligence, because huge amount of data on emissions and all are getting available. So a hybrid kind of a approach, what we call as a Iasta, we are working on that particular thing, and I will come to that point very quickly on that. So point is, this is again to show you that there are it is well taken care of, nucleation, coagulation, condensation, air quality, air, all those things, not in detail of that. But the critical markers, as I told that anybody can run the models and do that, but critical markers are for modeling is, you will have to have a stability, you should have to have a accuracy, you will have to have a positiveness, then speed, that all depends on the development, and then obviously on the center of this sitting the physics, which is you have to conserve the mass. So mass conservation is all about all the modeling, equation solving and all those kind of things. Well, those people who are youngsters who have not seen, this is one of those basically our classic paper where India's first maiden air quality forecasting or early warning system has been explained, environmental modeling and software, you can always see into that particular thing, so but it is just for your this thing. But coming to this particular thing, many things, now the problem is emission versus air shed. Not going to explain you more of a air shed, but it is related with the geographic, climatology and long-term trend which embedded the climate change related impacts also. So our focus has to be air shed based rather than a only emission based, and you will see the cities where the share of different sources are there, but total emissions gigagram per city per year is Delhi, after that comes Bengaluru, after that Mumbai, after that comes to Chennai, as far as the emission of PM 2.5 is concerned. But Mumbai is much more polluted than Bengaluru, although the emissions are higher. Similarly, Mumbai, this was, if you put it more, then more or less closing to Chennai, but Chennai is much better even than Mumbai, even than Bengaluru. So all those things are, there is a discrepancy. It is not emissions directly proportional to the air quality problem. So there are issues, and that is where air shed versus emission problem one has to see. Now, challenge of tomorrow. So I am coming into the different angle. At the end of the day, message is this, that instead of shortcuts, geoengineering, I think the major problem is you should have to target the emissions at the source. And that is where, you must have people seen that these are the number of, editorials and all keep on coming Mumbai, because Mumbai is becoming for last 2 years. This was one of those where I contributed. Another one was there, myself and Professor Tripathi also calculated, where we need to understand and trying to see that why Mumbai is becoming breathless and all. And similarly, these kind of things are there, which I shown you, that why Bengaluru is much better as compared to even Mumbai, because in spite of the fact that emissions are much higher, about 20 to 30% higher in Bengaluru as compared to that, because Bengaluru is one of those cities where two things it is looking for the Guinness of World Record. Number one, maximum number of two-wheelers on the road. Number second, maximum number of congestion on the roads. And the speed on an average is 22. So these are the things. Now, the extreme events which were talked about. Why Mumbai was on the news? Number one, in 2022, January to March, suddenly there was a air quality, you will see that, gone to the peak and then suddenly declines. I did not put the circles over there. These are different cities in western part of India. It's not only Mumbai, but many, this Surat, then, there are cities which you can see, Ahmedabad and all those. This thing which you talked about, all those. So the point was very clear that there was a dust storm, which always happens in Afghanistan and this, but normally it happens in January and March it doesn't happen. It happens in March, April, when the summer sets in. Not, but these are again unusual thing that during the winter, there was a huge dust storm, continuous dust storm, entered from there, there were westerly disturbances which has pushed those dust, did not allow it to go to north. So it is all stayed in this thing, and then air quality was one of the worst at that time, very poor. It has gone, and that is the way model simulates that how the things have gone from here, from this to those places. This is one of those events which has happened in January, March in 2000. Then you will see that in October to January 2022-23, see the air quality on the month October to January, whole October, November, there's some 4 months, winter. In southwest India, air quality has increased over the average of 19 to 22, past 3-4 years, by about 30%. Air quality last year in Delhi, where everybody was claiming, more so the authorities and governments, that, oh, we have worked very nicely, and then air quality has improved by 30%, 40%. Then those are the things. It has gone 30% down now. 30 plus 20 more, so it became 50 now, as compared to last year. And this is where the discrepancy. Why 30%, 40%, this improvement in one part of India, another, there is and it is not in one city. Many cities are there in those regions. So, well, teleconnections we are trying to see. This is there in the paper, you will see in month time, where you will see that unique triple dip La Nina, first of the century, an avatar of climate change, disturb large-scale wind pattern. Zone 1 in north, faster wind, faster dispersal, and improve air quality. Zone 2, peninsular India, calm wind, slower dispersion, and worsen air quality. These are the impact which we have proven that it has happened. So the same thing which I talked, it is explained in this. Central India tectonic plane, upper, down. 2 different signatures of air quality. And that is what one of those which you need to do further. Well, to prove much more that it is because of the large scale circulation, we try to do the modeling and see that with last year wind, whether we can get the better air quality in Mumbai. We did get it. So that is why it has proven. So not going in detail, but to show that these are the things. Then 2023, come to that. One of the best air qualities in 2022. One of the worst air quality for last decade in November, where this is only up to 10th of November, but when you'll see worst air quality day, severe days, which is emergency. In 2023, 15 out of 30 days were in severe emergency category. 10 of them in a row. Fortunately, by the grace of God, on 9th night, there was a shower. Otherwise, it would have given a world record on having for 20-30 days in a row. So there was air quality washed off, but then again it built up. So see, over the last 5 years, 2019, these many days were there, because severe days are something which is emergency, which normally very restricted. Last year was only 2. So you see 2 and 15, we've gone to that particular. So anyway, air quality was worse. These are one of those simulations where buildup of deadly PM 2.5, which is being captured in the model between 30th November 30th October to 7th of November. So by mistake, it is there. So all those things are there. Well, there are a number of things where we do it instantly. Dynamic emission inventories are being done, percentage contribution and all share. It has gone in 2023 by 43%. And although the peak was only for 15 days, but it was much higher in 2023 as compared to previous years. So all those things are there. But this is, as I promised in the discussion, we are involved in many new things. You have to think out of box, new things. and that is what the next generation technology, we need to embark on that. We should not get laid behind to that. And some of them, which I've been talking about, which we have been anyway in NIAS, in IASC, we have been doing it. Youngsters can think of it. So now next generation 3D data visualization, huge amount of data. Artificial intelligence is what? It is all about because why it was not there 10 years back? Because there was no data much. Now we have a huge amount of data, and that is what is the machine learning techniques and all those things can happen, all those. These are, I don't know whether it will play. Okay, so these are one of those which we started a drone-based data activity. It can convert into dynamic online, but these we try to do it Bangalore. We have been doing it for last 6 months. This where with the artificial intelligence, with the drone, you put it this, analyze it, you know, you see that it is identifying the number of vehicles at a dynamical time, at any point of time, and then it is trying to do exactly how many numbers of vehicles of different kinds of there, and then there are number of results. So this is just to show you that this technology are being done on that. Now, well, again, when you would like to see the areas where what is burning, what are the things which are focused on that particular, the big areas, slum areas, the kind of a construction activities and all, we try to see with these kind of thing, and then we are identifying on a real numbers on that. So the point is that the future is all about, not for today's emission inventory development, which anyway you need to do it, but dynamic emission inventory, try to have a drone-based artificial intelligence, Google real-time map, which is not available free of cost. You will have to subscribe to that. Have a GIS online methodology, get a emission hotspots. There are two ways it can help. Number one, action by the corporations and all immediately based on that. Another one is you can go on a further, because in Mumbai there is one thing you will see, if Kolaba air quality is satisfactory or good, you can have in Navi Mumbai or you can have in Vasi very poor air quality. Huge variability in weather, in temperature, in air quality too. That is all climatology is all. So this is something which is a part of that future thing, where we start with the bigger 400 by 400 meter resolution, get into the dynamic road emissions. So from this suffer emission inventory available online also. From there you get to 100 meter to 10 meter. This is, I'm talking about future. We started it, but then many people. So what you are trying to do, city level, which is being done at this moment of time in the modeling, 1.5 kilometer resolution in a domain which is 50 by 50 kilometer, the red line. Now you put it in another domain. So two domains, the last domain is this, which is like a mohalla, an area, and from there you get into the street modeling. So this is the next generation modeling, where you will try to see in a city like Mumbai, where you can have that, like this is in Delhi, for example, you see India Gate is that and Connaught Place, so you get into that kind of a thing. Accuracy, uncertainty, many things are there, but obviously, as in a traditional sensors are available, we need to, you know, science will complement the local sensors. Similarly, this kind of a modeling, I think it will head a lot of things in the time to come. So these are something which is being done, total hierarchy of this development of emissions. So the final thoughts on that thing is that while extreme weather or changing climate pattern take a heavier toll on the planet, new trends in frequency and severity of the air pollution is taking a toll on our health and food security. The general statements, but things, since it is happening like this, that is precisely the reason that COP28 is equally relevant for air quality community and people. I truly believe that health can be a game changer for air pollution, because climate change impacts are being felt in next decade. Our next generation, air pollution you will be suffering today itself. So emergency episode in all probability are set to increase in leap and bound. A science-backed drastic step to target the emission at the source using airshed approach is needed. Earlier so last slide is very important, last sentence. Earlier we overcome from geoengineering, cosmetic quick fix and trust deficit, better it will be. And that is where I will come to those two programs which you people can participate. It can come. One is that from the Office of Principal Scientific Advisor to Government of India. There is a program called National Air Quality Resource Framework. There would be 5 thematic modules for that, which is a resource framework, which our country is at this stage of time lacking. And that is what one of those where outreach is very important component, theme number 5. And the second one is that with the University G20, during that point, Prime Minister of India has launched U75, University 75, where a national movement for net zero university. So in the university, 75 university will be there. There would be volunteers over there. They will be simply measuring and finding out the greenhouse gas emissions. And although it will be almost negligible as compared to global or India, but then that will pave the way for many things, how to reduce carbon emission as a student at the university, net zero. And then I think this is particular thing which is being spearheaded in India by none other than ex-Minister of Environment and Forest, Mr. Javadekar. And that is something which is again university campus. There are people who are working and enrolling on this. Those universities who want to do that for a smooth transition to net zero. This is one of the steps where science can come with outreach, where it can inculcate in the feelings of that. So with this, I think I will close my talk. Thank you very much.
We'll take very quick 1 or 2 questions. Yes, please.
Yes, please. Go ahead.
So in the last slide, you said that controlling at the source. Don't we know the solution from last 30 years that the sources are known? Then still we are talking after 20, 30 years, even after 20 years, again we will keep on talking about controlling at the source.
We should keep on talking because we are deviating. We are doing the geoengineering. We are spending huge amount of exchequer's money in something which is quick fix.
Exactly, that's what I'm saying. I think if everybody knows this knowledge, right? That what are the sources? For taking an example of Mumbai, the dust is one of the important contributor. There is some other construction site. We do not have to have that precise knowledge of, okay, 20% or 30% is coming. We know what are the major sources. And it's not from some time now. In the entire country also. This is basically common sense to all of us, that the sources are known. You don't have to be that precise. It is all the enforcement and the implementation is the lacking.
So it is an enforcement and...
Personally, I feel a lot of work has been done, a lot of knowledge is existing. We need to really act upon it and make sure the things are fixed. Right?
So it is a science-backed knowledge. That is where the involvement of academic and scientific institutions are very important.
Sure. One more quick question, please.
Yes. Sir, boliye.
Wonderful presentation, sir. After a long pause, I could hear your one of the best lecture. The thing is that Mumbai, a few minutes back we were discussing on the Mumbai issue. And the issue is that Mumbai is suffering from PM10. Mostly is PM10. And if you really see the ground level condition for last 3 days or 2 days, what I've observed, huge amount of construction activities are on. Now the PM10 is the byproduct of all these development and construction activities. And one of the gentlemen rightly said that the guidelines are not being followed. And there is no punishment also probably. I do not know what is happening in it. And another gentleman was rightly said the quantitative, probably Madam Professor Brankata, the quantitative, how much we have reduced the emission over the years, that no figure is available across the country, no available. And number 4th is which one is most effectiveness. That is also not yet been studied using sensor, whether it is water sprinkling or pavement or curtain, whatever it is. No assessment has been created so far. So this is applicable at this stage and efficiency will last or applicable for this much of hours. That is also not there. And the countrywide, the problem, mitigation problem is also not there. It is a need-based, quick fix-based, as you told. Now the air quality is bad, now go for this. It's a continuous process
Yeah,
and
so Sahasab,
exercise.
So I think I got your message.
So how we can overcome these things? What would be your suggestion?
Important, this is where, so very briefly, I think they are short of time, very briefly about that particular thing. First, your thing is that it's very clear that in this time when there is a emergency events, it is a PM10 which is a dominant here in Mumbai, whereas a problem in Delhi is always dominated by PM 2.5. So that's very clear about that aspect of that. Coming to your second thing is that all these, there are many cities, although their emission inventories are very limited, but there are many cities where we now precisely know what are the relative contribution of the different sources are there. Delhi, we found out that for last 10 years, there is a 3 to 5% increase in emission. There is no decrease in emission, by the way. But then that's a remarkable feat, that 3% increase, in spite of the fact that vehicles have increased by 40%. So these things are there, but then implementation remains the issue, number one. Second thing is that science-based approach where the academics and scientific organization need to be an integral part of decision making, which has to be there, and that is where the problem lies. Thank you.
More discussion on lunch. Thank you so much, sir. Once again, a big round of applause, and I request Professor Chandra to present a memento to Professor Gufran.
Yes, ma'am. Thank you very much.
You can go further that side.
Okay.
A big round of applause, please. Thank you so much, sir. So without much delay, I would like to invite our next speaker, Professor Dilip Ganguly, who is also a very eminent atmospheric scientist. He does not need any introduction, but I will tell a few things about him. His broad research interest is to investigate the role of air pollution, and especially aerosols, in the climate change mechanism through their influence on the Earth's radiation budget. The tool that he is currently using is coupled chemistry climate modeling and air quality modeling. So I welcome you, sir, and over to you, Professor Dilip.
Yeah, this is okay. Yeah. Okay. First of all, I would like to thank the organizers of Iasta 2023 for inviting me to give this talk. And I would also thank actually Professor Gufran Beg, who made my job easier because the previous talk he talked about modeling. So in this talk I'm going to, one of the reasons why we need to study and understand aerosols is aerosols affect weather and climate. So that's the motivation. So in this talk, actually, I'll be discussing the results of a modeling work, which is part of this Ministry of Environment, Forest and Climate Change funded project called NCAP Coalesce, led by Professor Chandra Venkatraman from IIT Bombay. So we had a modeling team in that, which consists of Professor Chandra herself and her team from IIT Bombay, IIT Delhi, myself, Professor Sagnik De, and our students, and then Dr. Anand from BARC. So this is, perhaps everyone knows, but just for the sake of completeness, aerosols are known to affect the climate of our Earth in various ways, but broadly, IPCC has classified that aerosols affect the climate through aerosol radiation interactions. That means aerosols directly scattering on absorbing the incoming short wave or outgoing long wave radiation. Direct effect, which we used to call, we still call it, and then semi-direct effect. Together we call it aerosol radiation interaction. And then aerosols also affect the climate by modifying the cloud properties. There are various individual ways by which aerosols change the cloud droplet number concentration, their cloud albedo. They can invigorate the clouds, and that is how they can actually eventually perturb the radiation budget of our planet, and which will eventually change the atmospheric heating pattern and its temperature structure, and therefore it will influence the climate. But in order to understand how aerosols affect the climate, you need numerical models. So, and these numerical models actually need some inputs. So basically, for understanding aerosols, we have to first predict the aerosol concentrations. So this is developed in the form of emission inventory. So based on the human activities, different human activities, we prepare the emission inventories for different aerosol species. Then we use a numerical model to chemical transport model, which Professor Beg was talking about, to predict the atmospheric concentrations of these species. And then we need another kind of model where these concentrations will, you need a radiative transfer model. So these concentrations will affect the radiative transfer that takes place in our Earth atmosphere system, and then that will result in what we call radiative forcing, and then radiative forcing will in turn result in climate change. So in this talk, I'm going to basically, so Professor Beg already talked about atmospheric how models are used to predict atmospheric concentrations. I will just go one step further. From concentrations to radiative forcing. I'm not going to go to the full climate change. Probably Professor Chandra will present some results tomorrow. She is giving a plenary talk where how the forcing again affects the climate change. But today I will restrict only to concentrations to radiative forcing. Now, this concept of radiative forcing, again, I'm sure most of you know. So radiative forcing was defined by IPCC, Intergovernmental Panel for Climate Change, as basically a measure. It's a quantity which is a measure of influence of any factor that affects the incoming and outgoing energy of the atmosphere system. So a positive radiative forcing caused by any factor is likely to lead to warming of the atmosphere, and a negative forcing means it is going to cool the atmosphere. So now the definition of radiative forcing itself has evolved over past 20 years or so. So earlier in the initial assessments of IPCC reports, radiative forcing was computed as instantaneous radiative forcing, where the temperature throughout the atmosphere was held fixed, and the emissions were allowed to change, or concentrations. In those days, actually, the models were not, so the chemical transport model was actually offline. You calculate the concentrations, and then you prescribe those concentrations in radiative transfer models, where you also prescribe the temperature. So you don't allow the temperature of our Earth atmosphere system to change, and then just estimate the change in flux at the top of the atmosphere. That would give you, so you, the radiative forcing. But then in the subsequent reports, there were IPCC reports actually up to AR assessment report, AR4 actually, the radiative forcing that was estimated allowed the climate models to adjust the temperatures in the stratosphere, but the temperature of the troposphere was still held fixed. And then in AR5, actually, it was decided that no, that troposphere and stratosphere, both temperatures will adjust when you change the emissions. They will adjust, and then you calculate the change in flux. That is the radiative forcing. But in the current assessment report, AR6, actually, so here the temperature, the surface temperature used to be fixed, but now even only the sea surface temperature is actually fixed, and then you change the emissions from pre-industrial to present day, and the atmosphere throughout the temperature throughout the atmosphere, troposphere and stratosphere is allowed to respond. But this includes only the rapid adjustments, not the full-scale climate response. So you run the model with fixed prescribed SST for a couple of years, and then calculate the change in fluxes at the top of the atmosphere to quantify what we call effective radiative forcing. So the concept of radiative, even the how you calculate the radiative forcing, means the direct radiative forcing, that means the effect of aerosols on the net radiation balance at the top of the atmosphere through absorption and scattering. That definition has also changed from the previous IPCC report to the current IPCC report. So up to AR5, the aerosol radiation interaction, the impact of aerosol radiation interaction on the radiation budget was estimated as basically by computing the change in the clear sky fluxes at the top of the atmosphere. And the aerosol cloud interaction was computed by, so this delta means basically you do two simulations, one for present day, one for pre-industrial, and compute the difference. And for cloud radiative forcing, it was basically all sky fluxes minus clear sky fluxes for the present day, and then subtract it with the all sky minus clear sky for the pre-industrial. So, and the total is just the sum of these two. But from the IPCC AR6, the definition of this aerosol radiation interaction and the estimates of effective radiative forcing and the effective radiative forcing due to aerosol cloud interaction has also changed. So now we have another, so the models are asked to calculate an additional diagnostic flux, which is known as F clean. That means the flux under clean atmosphere. There is no aerosols in the atmosphere. So this is a diagnostic flux. So actually what affects the climate is the all sky flux, F. So direct radiative forcing is calculated in this way. So F minus F clean and then PD minus PI. Similarly, cloud radiative forcing is calculated this way. And then we also have a residual forcing, which is the delta, the flux change under the clean and clear sky conditions both, which is actually the aerosol-induced, largely aerosol-induced surface albedo forcing. So this definition was actually introduced in this by Steve Gahn through this paper, which has been adopted by IPCC and all the intercomparisons. So here I'm showing you, as I said, I'm going to present results for a model intercomparison that was conducted as part of this NCAP Wallace project. So here I'm showing you just the column burden. So in this project, actually there were 4 models which participated in this. So this is CAM5 model, and CAM6, these are NCAR CESM model basically. The previous version of the NCAR CESM is CAM5, the current version is CAM6. Then we have a German model which is the ECAM, and then there is a Japanese model, NICAM Sprinters. So we use these 4 models. So what is shown here is basically the comparison of column burden of different aerosol species, black carbon, organic carbon, sulfate, dust, sea salt, is simulated by the different models and with the comparison with MERA2. So the detailed comparisons with more information is available on 2 papers that we have published as a group. These 2 papers, you can read those. And then what is shown here on the right-hand side is basically the change in the column burden of black carbon, organic carbon, and sulfate as simulated by the different models. And as I said, radiative forcing is all about calculating the changes in the fluxes at the top of the atmosphere, and also at the surface, you can calculate the surface radiative forcing. So what I'm showing you here is the evaluation of fluxes estimated by the different models, and comparing them with the fluxes that are available from MERA2 as well as the series. So the NICAM Sprinters actually could not provide us the diagnostic fluxes under clean condition and clean clear condition, so that's why we don't have that, and series also doesn't provide that for the short wave at the top of the atmosphere, so we have this missing. But so this is for the top of the atmosphere, and this is for the surface. So you can see that although the models, there is a lot of variability in terms of aerosol concentrations, but they fairly, they do a fairly good job in terms of estimating the fluxes, the radiative fluxes at the top of the atmosphere and surface, very much comparable with the satellite data or the reanalysis data that we have. So now I'm showing you the aerosol radiative forcing. So what this plot is showing is the annual mean shortwave radiative forcing at the top of the atmosphere for the period 2005 to 2014 as simulated by the 4 models, but we could not derive the, and also we have here, this is the total radiative forcing, and total radiative forcing is the sum of the radiative forcing due to aerosol radiation interaction and aerosol cloud interaction, and there is a residual forcing. So, and these are the different models, CAM5, CAM6, ECAM6, and NICAM. So what you see here is that due to change in aerosol emissions from pre-industrial to present day, and these aerosols interacting with the short wave radiation through absorption and scattering, if you only consider that, then you can see that the direct radiative forcing, or ERF ARI, is kind of positive over the Indian region. But ERF ACI, which is cloud radiative forcing caused by aerosols, is negative and has a larger value. And so the overall effect is basically a negative radiative forcing in the short wave at the top of the atmosphere. That means aerosols are actually going to cool the atmosphere. Negative forcing cools the planet. And this is the radiative forcing in the long wave. So for the climate, if you want, because the climate of our Earth is affected by not only the radiation which comes from the sun, but also the radiation that is emitted by the planet Earth, which is in the long wave. So we need to understand, do these aerosols perturb the long wave radiations also in some way? So as we all know that aerosols do not affect that much significantly in the long wave through scattering and absorption, but you can see here that aerosols do have an influence on the long wave radiation budget through aerosol-induced changes in the cloud. So what is happening here is the positive radiative forcing means basically the aerosols are changing the clouds in a way that is resulting in the trapping of the long wave. So this is a positive radiative forcing, and this is the net. So this is dominated by the aerosol-induced changes in the cloud. And this is the sum of the short wave and long wave, because that's what affects the climate. You have to, so in radiative transfer, you have to always do the computations separately for short wave and long wave, and then you have to add them. Of course, the climate model does everything together. But we need to, in order to understand how exactly it is affecting the incoming and outgoing radiation, you need to analyze them separately. So what is shown here is that the net radiative forcing estimated by the different models. So you can see that overall over the Indian region, all the models are suggesting that the net radiative forcing, which is sum of short wave and long wave, is negative. Of course, there are some areas where there is a positive radiative forcing also, and that is coming largely due to the aerosol radiation interaction. And through aerosol cloud interaction, it is negative. Now, in addition to estimating the radiative forcing due to all the aerosols that changed from pre-industrial to present day, we tried to understand the contribution of individual aerosol species. How did they contribute to the net radiative forcing or the short wave radiative forcing or long wave? So here, what is shown here is, of course, these estimates were done using only one of the models because it requires additional simulations. And so the top panel is basically the sum of the radiative forcing due to the individual components. But here, this one is for BC, for example. You can see that if you only the black carbon aerosols change from pre-industrial to present day, that results in a positive radiative forcing over the Indian region. So that is largely coming from the aerosol radiation interaction, but aerosol cloud interaction is still, even the black carbon produces a negative radiative forcing. But because the positive radiative forcing is higher than the negative radiative forcing, overall effect is positive. That means it is going to warm the climate. But sulfate is negative for both aerosol radiation interaction and aerosol cloud interactions. Overall is more negative, more cooling. Organics is also similar to that. This is for the long wave. As I said, we need to calculate for short wave and long wave both. Interestingly, the total radiative forcing that we had seen earlier, it was negative in the long wave, and that is coming largely due to aerosol cloud interaction, and you can see here that is happening, at least in this model. This is results from the CAM6 model, is happening due to the changes in the emissions of sulfate aerosols. So sulfate aerosols are changing the clouds in a way that is resulting in trapping of more long wave radiation. And this is the net radiative forcing due to the individual aerosol component. So this is the total ERF, and this is the aerosol ERF due to aerosol radiation interaction, aerosol cloud interaction, and this is the residual one. So here you can see that the BC is positive radiative forcing, the net sulfate overall it's a negative radiative forcing, organics is also negative radiative forcing, and their sum is also a negative radiative forcing, but there are areas where radiative forcing is positive. This is basically, I'm showing you the comparison of radiative forcing. So radiative forcing is usually, in IPCC reports, it's calculated always at the top of the atmosphere, because that's what affects the climate. But one can also calculate radiative forcing at the surface of the Earth. This is, so one interesting thing, you see that here you see a lot of colors. BC is positive, sulfate is negative. The total also is some positive, some negative. But here at the surface of the Earth, you see that radiative forcing is negative. So atmosphere, there is some warming due to aerosol radiation interaction, but at the surface, regardless of whether it's a BC or sulfate, they are all cooling the surface. So this radiative forcing that I mean, of course, for the climate, this is more important, but this one, how the fluxes are basically changing at the surface of the Earth has another importance. So one of my research objective, or one student actually is working to understand how the aerosol concentrations that we have in the atmosphere, how they affect the renewable energy, solar power. So what we have published some 2 papers on this topic, where we show that basically, of course, India, as you know, the government has announced that it wants to increase the total production from the solar and wind to like more than 100 gigawatt or so. But what we have shown is that currently, of course, this is based on 2018-19 data, that installed capacity was 28 gigawatt, that means 39 terawatt hour of energy that is generated. But what we showed is that because of the air pollution that we have over India, actually there is a, basically there is the GHI that is used, global horizontal irradiance, that is, has to be more than 5 units basically. That has decreased by 29% over the Indian land mass due to increases in aerosol. So that is resulting is actually in terms of, if you, because electricity, there is a cost to that. So because you are generating less electricity, how much in terms of money we are losing. So we actually showed that basically there is a huge amount of monetary loss that currently the solar power sector is happening due to. So we must mitigate the air pollution if we want to. Of course, India being close to the equator, we have a lot of sunshine, but if you want to take advantage of the solar energy that is available naturally to us, you need to clean the atmosphere. So with that, these are the summary and conclusions. I have already discussed this thing, so I'll stop here.
Thank you so much, Professor Ganguly. So the house is open for questions. There is one. Can somebody give the mic, please? Can you please come a little forward? After this, we are taking one more quick question, and then we proceed for lunch.
Very nice presentation, sir. A lot of information. I have one query. For radiative forcing estimation, there are 3 important parameters: aerosol optical depth, single scattering albedo, and phase function. So basically, we need a vertical profile of all the parameters, basically different levels. So how did you consider the vertical profile of a single scattering albedo, especially? So that determines the sign of forcing at the top of the atmosphere.
So these are model estimates. So in the model, actually, we prescribe the emissions and then the entire life cycle of aerosols, from the emissions, their transport, their transformed chemical reactions, they are getting transformed physically and chemically, and they are eventually removed from the atmosphere. Everything is simulated in the model. So the vertical distribution of aerosols is also simulated in the model, and those aerosols are interacting with the radiation and causing the radiative forcing.
Yeah, sir. Did you validate or compare this model simulated profile with the?
I mentioned two papers that we have already published, which extensively has validated.
Yeah, yeah.
Of course, there are deficiencies in these models, huge deficiencies, but we cannot wait for all the deficiencies to be resolved and then try to understand. We have to move things parallelly.
Yes.
So there are deficiencies in the model, but still, at least we know the sign of radiative forcing, whether it is going to warm the climate or which species is going to warm, which is going to cool the climate. That information we can get.
Yeah, yeah. Thank you.
One more quick question. Okay, that corner.
Hello, sir. Thank you for the informative presentation.
Keep your mic a little closer.
Audible?
Yes.
Yeah. Sir, you showed a flow chart where emissions to concentration. So, sir, if I see this Edgar or Eclipse inventories, so I think last is 2018 or something, we don't have the data. So, sir, if someone wants to, and this climate models need high computational setup to bring some output. So, sir, if someone need to do this calculation from emission to concentration, so what should be the approach?
So, from emissions to concentration, if that is the only objective, then you should use chemical transport models, which Professor Gufran Beg was talking about.
Yes.
So, you don't need a climate model.
Okay.
And in fact, regional models would be better. They will give you better concentrations.
So for recent years, if I want to go from emissions to concentration, so can I follow these models?
Yeah, you use a chemical transport model.
Yeah, thank you. More discussion on lunch. So once again, a big round of applause, and I request Professor Pretsinis to please honor the speaker. Oh, I'm sorry. This side it is. Yeah. Thank you so much once again, everybody. So we meet after lunch. I request those who are having oral presentations, please check your presentations in MH1 as well as MH2. Thank you so much once again.